that. All right, it seems to be working. And we'll go back. Oh, for Pete's sake. Okay. All right, yes, sir.
Can you make sure about the sound?
Yeah. And now I'm going back to the recording board. So now it's actually recording me and doing sound. And we'll try this again. Okay, so step number 3 is also kind of a rewriting step, but it requires a little bit of kind of more information, how we're going to rewrite. So step number 3 is to rewrite with all terms. So the question we have to ask ourselves here is we have to ask ourselves, do we have a term for every unknown in every equation that we have? So we go through the equations again one by one. So I look at equation number 1 and I say, let's go back. And I say, in equation number 1, do I have a term for all 3 of my unknowns? Yes, right? So for this part of the problem, I'm not going to need to do anything for equation number 1. For equation number 2, do I have a term for all of my unknowns? Yes. For equation 3, do I have a term for all of my unknowns? Yes. So in this problem, I don't have to do anything for step number 3. I don't have to rewrite my equations. I don't have to add anything else to my equations. When would I do that? So if I had an equation, if let's say equation number 1 did not have a TAD term in it. It didn't have that term. That variable wasn't in that equation. What would I do? It says I need to add what's called a zero coefficient. So I need to have every equation have every term in it. If it doesn't originally have that term, I write a term that might be something like 0 times TAD. And that just kind of is a placeholder to say, I don't have that term in my original equation, but I'm going to need it to kind of add it in there. And by putting a 0 in front of it, it really doesn't change the algebraic kind of expression of the equation. It's just kind of a placeholder to put in there. So that doesn't apply for this problem, but it will apply for number 2 on your, in-class exercise. So we'll kind of revisit that next time and kind of remind why we're going to do that and where that comes in. So for these equations, we said we don't need to add any extra terms. So again, we really don't need to write anything. So I'm just going to, in general, say equations 1 through 3 are okay. We don't need to do anything for this step. So now we move on to step number 4. Step number 4 is to collect coefficients into our A matrix and our B vector. So this is kind of filling in the other 2 parts of our general form of our linear system of equations. We said what x was. We told MATLAB what that was. And now we need to figure out step number 4. So I'm going to start 4 here. So step 4 is to write A and B kind of in shorthand. So what goes into A? So A contains, just as like notes, A contains the coefficients in the unknown terms. So what do I mean by that? My A matrix comes from all the unknown terms that I have. So in equation number 1, I pick off all the things that are multiplied by my unknowns, and I pluck those out and I put them in my A matrix that I have. So my A matrix is going to be a big matrix, and it's going to be kind of organized just like I have my equations here. So I'm going to have 3 rows in my A matrix, 1 for each equation. And I'm going to have 3 columns in my A matrix, one for each unknown that I have. So I kind of pick off my numbers. So my very first row of my A matrix are going to be the coefficients for my first equation that I have. So I've got 0.667, I've got negative 0.408, and I've got negative 0.514. And this is for equation 1. Kind of write that shorthand out on the side. So what am I going to have for equation 2 that goes in the next row? What values? 0.667, 816, 0.816, and 0.686, right? And then my last row is for my third equation, 0.333, negative 0.418408, and 0.514. And that's from the last equation here, equation number 3. Right? So it's really just picking that stuff off, putting it into the A matrix. Yes, sir?
So if you would have done different x, would you have to change that matrix first?
Ding, ding, ding. So this is where the order becomes the problem or the issue. And that's where it becomes the important thing to make sure you've established your order correctly. So whatever order you pick here, TAB, TAC, TAD, that establishes the order of the columns here. So just like I label these rows according to equation, I could potentially label these columns according to what variable that they kind of line up with. So like I said, whatever order you pick over there has to now be consistent with your A matrix. So if I would have picked TAC, TAB, TAD, then I would have had to switch around these columns that I have here. Questions about that? So we have our A matrix. Our A matrix always has the number of rows equal to the number of equations. So number of rows equals number of equations. And our number of columns equals our number of unknowns. So for determinate systems, we always have a square A matrix because we have the same number of unknowns as we have equations. Any questions about anything so far? All right, so the other part of step number 4 is to write the B vector, right? So our B vector contains what? So what have we not put into an A matrix or an X vector yet? We defined X, we defined A. What do we have left?
W.
The W, right? So the stuff we moved over to the right-hand side in step number 2. So for equation number 1, what is that going to be? So let's stick B over here. It'll be short. B is also a column vector, so it's going to be up and down. So what's going to be over here? 0. What's going to be in our second row? W block.
100.
Or 100, whatever we decided it is. And then what's going to be in row number 3? Another 0. So when we think about B, these are all of our known terms or values. So now we have defined all the parts of our general linear system of equations. We've got X, we've got A, we've got B. And just as a note, so how do we know kind of what B is? So B has 3 rows, or let's say in general terms, number of rows equals our number of equations. So it's always going to have the same number of rows as we have equations. Same rule for x. This is number of rows equals number of equations. We kind of want to keep an eye on that just to make sure we didn't screw anything up, we didn't leave anything out. So we always kind of want to double check and make sure, did we get x is the same size we wanted, a is the same size that we want, and b is the same size that we want. And that's kind of how we double check and make sure we set everything up correctly. So step number 5 is really to just kind of put it all together and make sure that it makes sense, make sure that a and b and x kind of all make sense together. So a lot of times I don't even write anything for step number 5. It's kind of just a double check and make sure I didn't leave anything out kind of step. Any questions about that? All right, so at the beginning of class, Wednesday, after the quiz, we'll talk about how do we put this stuff together and actually solve for something in MATLAB. So don't forget, quiz on Monday. I will probably be in my office Monday anywhere between like noon and class. So if you have questions before the quiz, come by, please. Otherwise, send me an email over the weekend. Everybody have a fun and safe Halloween.